Hello everyone, welcome back to the Decode with Pankaj. I am Pankaj. In this video, we will quickly revise business intelligence, K-mean clustering, K-Medoid clustering, DBSCAN and hierarchical clustering. Some of the most important topics from Unit 3 of Data Mining and Warehousing, SPPU Third Year AIML department. So let's begin. Definition: Business intelligence is a collection of technologies, tools and techniques used to collect, store, analyze and present business data to support decision making. Business intelligence helps organizations convert raw data into meaningful information. Examples: a supermarket analyzes customer purchase data to determine most sold products, peak shopping hours and customer preference. This information helps to improve sales and profits. Objectives of BI: improve decision making, increase business efficiency, identify market trends, improve customer satisfaction and gain competitive advantage. The components of BI is information sources, data warehouse server, overlap servers, client 3 clients and tier 3. Okay, so in which the extract, transform, load, also this is process, operational databases, external sources, metadata repository, data marts, data mining, key performance indicator and data analysis. Okay, so this all information. The component first is data sources, in which it includes databases, ERP systems, CRM systems, web data and ETL process, in which extract, transform and load. Third is data warehouse, in which stores integrated historical data. For data mining and analytics, discovers useful patterns. Fifth, reporting and visualization, displays information through dashboards and charts. The advantages of BI is faster decision making, better forecasting, increased revenue, improved operational efficiency. And the limitations of this is high implementation cost, required skilled professional and data quality issues affect results. Okay, so second concept is K-mean clustering. What is K-mean clustering? K-mean clustering is an unsupervised machine learning algorithm used to divide data into K clusters based on similarity. The working principle is select number of clusters K. Step 2 is randomly choose the K centroids. Step 3 is assign each data point to nearest centroid. Step 4 is calculate new centroid. Step 5 is repeat until centroid stop changing. The flow diagram is first is start, then input number of cluster, then calculate the distance between the clusters and the data points, then group based on minimum distance, and if cluster are stable, then yes, then stop, otherwise recalculate the centroids and then calculate the distance and then iterate this. Okay, so next, this is also the flow diagram. Okay, so then is this is our chart, in which these points, these black dots are our centroids and these all points are our data points. Okay, so feature 1 and feature 2. Okay, the example is data points 2, 3, 3, 4, 8, 7, 9, 8. K is equal to 2 means number of cluster. Okay, so cluster 1 and cluster 2. This 2, 3, 3, 4 and 8, 7, 9, 8. And the centroids is this 2.5, 3.5 using the Hamiltonian distance. Okay, the advantage of K-mean clustering is simple and fast, easy implementation, efficient for large data set. Clustering of application with noise. Okay, so what is definition? The DBSCAN is a density based clustering algorithm that groups closely packed data points and identify outliers and noise. The important parameters is epsilon and mean points. Epsilon, radius around a point, and mean points mean minimum points required to form a cluster. Okay, so type of points: core point, border point, noise point. Core point, what is, has at least minimum points within the E radius, and border point is inside cluster but does not satisfy minimum points, and noise point is does not belong to any cluster. The diagram of this is this. Okay, so in which this is the radius, means this is E point, a radius of the ideal shape. Okay, so then this is the center point and this is the data points. Okay, these and okay, so according to that, these are border points and these are core points. Okay, that's it. And the DBSCAN clustering using the scatter plot is look like this. First cluster, second, the minimum points is 4 and epsilon is equal to 1 unit. Okay, then their algorithm is step 1, choose epsilon and minimum points. Step 2 is find neighboring points. Step 3 is identify core points. Step 4 is expand clusters, and step 5 is mark remaining points as noise. Okay, the advantage of the clustering is No need to specify number of clusters, detect outliers, work well with irregular cluster shapes. The disadvantages of this is difficult parameter selection, poor performance with varying densities, and the application of DBSCAN is fraud detection, GPS location analysis, and image processing. The next concept is K-Medoids clustering. Okay, what is this? The K-Medoids is a partitioning clustering algorithm similar to K-means, but cluster centers are actual data points, medoids, instead of mean values. Okay, so in which working of this clustering is: step 1, select K-Medoids; step 2, assign data points to the nearest medoid; step 3, swap medoids with non-medoids; step 4, calculate total cost; step 5, keep swap if cost is decreased. Okay, then the diagrammatic difference of both: this is K-Medoid cluster and this is K-mean cluster. Okay, according to this there are the differences. Then this is the algorithm: start, number of clusters, and medoids of clusters, distance, object centroid, swap with each object, nonlinear, and this is overall the diagram. Okay, that's it. And then this is a scatter plot in which we get these points, centroids, medoids. Okay, sorry, medoids. The difference between K-means and K-medoids is: K-mean uses mean, K-medoid uses actual data point. K-means is sensitive to outlier, K-medoids robust to outliers. K-means is faster, K-medoids is slower, and centroid may not exist in data set, medoid always exist. Okay, so advantages of K-medoid clustering is less affected by noise, better clustering quality, and the disadvantages is computationally expensive and slow for large data set. Okay, the fifth concept is hierarchical clustering. What is hierarchical clustering? Hierarchical clustering creates a hierarchy of clusters represented using a tree structure called a dendrogram. The types of hierarchical clustering is: first is agglomerative, second diffusive. Agglomerative is bottom up approach in which each object starts as separate cluster. Clusters are merged by step and most commonly used. The divisive is top down approach in which all objects start in one cluster and clusters are divided repeatedly. Okay, and the dendrogram of this is hierarchical clustering dendrogram. This is 2 0 1 4 3 5, it is the data points, and this is our dendrogram. Okay, so then this is our agglomerative means in which bottom to top. Okay, so first we get ABCD, these points. Okay, from that the B and C point are close together, so that's why we cluster of there, and D is also close together, so therefore we get the cluster of here. Okay, so using that we make another cluster and we connect both these two cluster and make big cluster, and using that in which we add the A data point, so that's why we get the big agglomerative clustering. Okay, so that's it. And next is hierarchical divisive clustering in which we get the A, B, C, D, E, F, G all data points and we divided it like merge sort. Okay, in which in the merge sort what we done, in merge sort we get the particular array and in which we divide them. Okay, so same as it is here. And the agglomerative clustering steps is: treat each point as individual cluster, calculate distances, merge nearest clusters, repeat until one cluster remains. Okay, the advantages of this is: no need to specify K initially, produces hierarchy of clusters, easy visualization through dendrogram. Okay, so disadvantages of this is computationally expensive, difficult for large data sets, and applications of this is gene sequence analysis and customer segmentation and document clustering. Okay, so from that overall this unit 3, the most important exam questions from the unit 3. Okay, that is error. Okay, so unit 3 is frequent as 8 to 10 marks question is: first, explain business intelligence and its components, explain K-means clustering algorithm with example, explain DBSCAN clustering with suitable diagram, compare K-means and K-medoids, explain hierarchical clustering with dendrogram, differentiate DBSCAN and K-means, and explain advantage. That's it for this revision video. I hope this helped you quickly revise these important unit 3 concepts. If you found it useful, like the video, subscribe to Decode with Pankaj, and join our Telegram channel for more exam resources. Thank you for watching, and I will see you in next video.